The 1st of August 2025, it's been an absolutely beautiful evening. It's lovely conditions for doing anything. We'll probably only have another 6 weeks of it. Now, this is the homemade cap for the hydraulic fluid tank of a vintage machine. And the owner of it once asked me to do it, and I have another job to do for another vintage tractor, a clutch rod, and it's quite difficult, but I'll tackle it all the same. Now, I hardened and tempered these cross members here. Do you see them here? I just use a drill bit here to point. See them here? So they're at an angle. Now, the thing is, this is a part of a piston of a car with a flat top. And what I would have liked to have here, if I'd have a lorry piston or a tractor piston that size, I could have carved the whole thing from the aluminium. Aluminium is for purposes like caps for fuel tanks and fluid tanks. Aluminium is the creme de la creme. It's so easy machined. Now, what we have here is we have the cross here to catch in the tank like any other tank top. And then this fits down. And now I had to get this ring here. Do you see the ring here brazed? And do you see there it's brazed on it now? Adequately brazed, more than enough strength. More than enough strength. And degreased it with acetone. And there has to go a spring. It's hard to get it to hold firm. There has to go a spring in here, in there. Sorry, it's just a bit awkward to get it to hold. So there has to go a spring in here under that. I have the spring already. Always wise to keep old springs. That's a bit dusty, but that's the idea. That there will fit precisely on that 12.5mm bolt, and that'll put a little bit of spring in it. And I might do just a brief video before I fit it. The owner doesn't want the machine to be associated with the channel. I think he feels it's a bit political. I'm a bit political. Now, do you see, there's two pins. Do you see the two pins here? See them here? One here. See there? And one here. See it there? And they go down. They're brazed in place. With I think it's only a 21% silver brazing. You don't need much silver at all. In fact, ordinary brass would do there. Took a lot of temperature to get it up. But so they go down here, and they mean that this can't spin. This has to be locked to the top piece. Now, as I say about a big piston, you'd have a lighter component, and you'd make it easier on the lathe. So in future, I won't be getting rid of any old flat top pistons. They're absolutely great. There's a lovely piece of aluminium, and you see, they're designed to run as a piston, so they're designed to wear. Now, that's the slot there cut. Now, you see the gasket. The gasket here is the bottom of a lunchbox. The bottom of a lunchbox. I have a double gasket, two of them in there, and I'll leave it down here a bit, if I can get this to quiet. An O-ring has to go in here. I have the O-ring to go in to seal it. So when she's tightened up and all ready to go and fitting perfectly, I've already given it a trial fit. I'll put the O-ring on it and then trim this off and put a lock nut on here that this won't move. You need to leave it that it can come off again. So you see the way it works. There's a gasket, plastic, the bottom of a lunchbox, and it should work perfectly. And then this goes in here. Now, the most important bit, this original was lost, so that bolt will be adjusted till it's just tight here, and that means that there can be a chain put on it, that it can't be lost. Because what very often happens is people top up a tank and they forget to put the cap on it, and that's the phone often rings and does that. So there'll be a slot here. Do you see it here? Do you see the slot? Sorry, now, do you see the slot here? And I'll cut that enough and get the chain in and then braze this really strong brazing. And that means that will be attached to the machine. And this can't be lost. It's not that heavy. It's about a pound weight, I suppose. Wouldn't be a kilo. Wouldn't be as heavy as a kilo of a litre of water, about half a litre. It's a bit too heavy, but not too bad. And this machine, the tank on it, is as strong as an ox, really good. So it'll keep it down on it as well. So I think I've dealt with everything there. Now the thing to remember is you never make parts like that for a machine unless it's running. That's the last thing you do. You could end up spending maybe 4 bits of evenings on that there now, making that. And then if the machine doesn't go, it's lying there. So you only do the fancy work and the trimming and the little extra bits after you have everything else going. You don't waste time. Now, there was a lad there, was he Sullivan? Posted. I think I'm not sure, it's a name anyway. You know the way they're always use a name. And he asked a question about milling in the lathe. And this applies to a milling machine as well. And backlash. Now, the first thing, I've just put, I haven't any work on this because it's too late at night and soon be going to bed. But the thing is, if you have work here in this lathe, you saw the slide, I had the slide here, you see. So if you want to mill in the lathe, or you wanted to face off a piece of material like this here, suppose you wanted to have this made perfectly, perfectly milled, you want to mill it. You can, a cutter like that is ideal, provided you adjust the speed down. The bigger the cutter, the lower the speed. Like this is a milling cutter here. You'd run that faster. Now the tables are in the books. If you're doing any of this, you'll get the relative tables on cutting speeds, and they can be worked out using pi. But it's important to keep roughly within the speed. Now, modern tungsten carbide is a bit more relieving. It'll work on higher speed, but ordinary tool steel or high-speed steel, you have to be careful. But high-speed steel can do beautiful work if you do it right. Now, if you're sharpening that in the lathe with a grindstone or even an angle grinder or a Dremel tool, you have to take great care to make sure that you cover the bed. The chips that comes off a grindstone will wear out the bed lathe. And if somebody's using a lathe and doesn't know that, and you're buying a second-hand lathe, that's something to watch for. I'd know it the minute I'd see it. You have to cover it. By right, you'd want to cover it with soft plastic, stuff like a cotton pillowcase, and maybe another piece of material, like a sheet. Old sheets should be kept, and it'll catch the dust. You must not let the dust out. And after you do your grinding, you must clean everything off. Do not let the grit from a grindstone get on your lathe bed and your lathe saddle. It's disastrous on the cross slides. I never did it, and it pays me because this lathe would be well wore if I had been doing that. It's not the right way of sharpening stuff, but it can be done. There's a knack in it. We won't deal with it here. Now, when you're milling, remember your slides, your saddle here, down on the bed. See it here, there. Your cross slide here, and your top side here. If they are all tight, that's all right, but you can't be sure they're tight. You must put the pressure downwards, never up, never up. You never move your work in, we'd say, like this, in that situation, you see? You never move it in. Why? Because you're lifting everything up. You're lifting all your joints. Instead, you must revolve it just like that there. See the way it's going there? I'll show you again. And that means that when it's cutting, it's pushing down the work, down on the bed. And that's vital to understand. Now, the other thing about backlash is you always feed the work in. You make sure that the lead screw is pulling in towards it. You see, like that. Now, if you're going to mill that way, you can do it. But you don't have any backlash when you engage it. You have to press it. The best example would be if you're drilling a hole with an ordinary drill press or electric drill or any kind of a power tool. You have to put pressure on it. You never allow it to pull in. It can't be allowed to pull into the work. If, for example, you introduce this like this, let's see now. Now watch. See, that can pull over. It'll not do it with my hand. Do you see that? Do you see the shape? Now it's difficult for me to show you that. That's backlash. Now some people want lathes and milling machines with no backlash. I wouldn't be comfortable without backlash. You bring your work up and you have the pressure on it, and you either do it by hand or you turn on your power feed. But the thing is, it's a continuation of the existing screw that's moving it. You do not let the work push it like this. You know, I can't do it here now because, now see, you don't let it in here so the work can pull it in. If the work you're doing pulls it in, it's going to dig into the work and break all. You can't let it pull in like that. Now the other thing too, if you are milling with the part of this, the bottom part, right, we'd say like that, it'll tend to pull it in as it goes to there. Do you see that? That there will tend to pull it in. So you don't want that. If you go pushing this in and suddenly it pulls it in, well, you have it moving maybe a millimetre out of control. You always run your work this way. Well, I'll show you now. Up here, do you see? Up here. So that it's pushing against the lead screw. The lead screw is already engaged. And also when that goes to push, it'll push it back against the lead screw. You must not have it pulling the lead screw away. Now I'd say that some people don't understand what that means. But essentially, if you see this here, the little bit of shake, see that? It's about 2 millimetre. That's quite normal. I'd be very happy with that. I wouldn't fault the machine for a bit of backlash. I don't know why people don't want it. I suppose with modern computer-aided design and all that sort of stuff, they might think it's a problem. But if you have that bit of shake and you feed it in like this, when it gets going against the bottom part here, like that, when it goes to cut, it'll start to pull in, and that means this will be pulled in. So it'll get this, do you know what I mean? It'll push it. Do you see now? It'll be like that. See that? It'll pull it in, and that'll do damage because you're feeding it in maybe a millimetre. And the trouble is you're going to have a jam. You must be feeding it against the direction of the support. So if you have it this way here, it can't push it. You're pushing this in. It has nowhere to go, only to mill. But it mills under a controlled way. You never let it run free. Never, ever let it run free. The other thing is that you must avoid unnecessary overhang. Have everything as near to the main bearing as you can. Some people, you see them work away out here. Reduce overhang to an absolute minimal. Now, somebody mentioned there, I was mentioning before about the smoke. A lot of people don't understand about the smoke. If you want very, very fine surfaces, supposing, for example, you wanted to fit that there in something you're doing. You want to fit that into a hole. And you want the hole to be a perfect fit, so that just a bit of hand pressure will move it in and out. There comes a time when measuring equipment will not suffice because, well, with modern CNC machine, it might a bit, but no, you have to set up it, and they're not precisely accurate. So for very, very delicate or very precise work, they used to use, and they still do in good shops, but it's kind of gone obsolete, but I would use it all the time. They use the smoke of acetylene. So what they have is a wee lamp, like a little inkwell, and a little wee nozzle on it. And you put a wee bit of carbide into it, and you wet it, and the acetylene gas comes up, and you light the acetylene gas, and you just run this at it, and it gives it a little piece of black smoke. And acetylene is a very black. So when you have that done, if you push that in and it comes out, it should be shiny. That means it's taken the smoke. If, on the other hand, the smoke remains on it, then it's cleared the smoke. Now, it's hard to think of exact examples, but in certain very precise work, it's essential to have the fit exactly as you want it. So if you wanted to take the smoke, you'll get it to a fit where it'll wipe the acetylene smoke away completely. And then you know that the acetylene is only a couple of microns. Ordinary acetylene smoke, I don't know, would it be 4 microns? Mightn't even be that. It's as thin as you'll get it. And that's acceptable in many industries and was always down through the years. Now, an example of it would be if you had a very, very expensive watch. The back, with an ordinary watch you'd buy, they just put in the back. But with an expensive watch, the back would have to fit tight, very tight, but not to need excessive force. So what they'd do is they'd put smoke on the back part, the part that you shove in to protect it, and it goes against your arm, and you'd push it in as it is meant to be sold. And when you take that out, you'd expect there to be no smoke left. No smoke. If there's any smoke left, that watch would go into seconds. And that's what you'd very often be getting if you're buying seconds in an expensive watch. I'm talking more of a tick-tock watch, but even the modern electric ones, the back has to fit in fairly right. So for a cheap type of thing, just bang it into it and make it a bit tight. But for really expensive Swiss watches and all that, they'd make the back of them clear the smoke. And also in the small gear wheels that's inside in watches, horology they call it, and clocks, they might make all the surfaces running so close but yet not touching. They might have the smoke left in. And smoke, a lot of people wouldn't believe that. They think you're only pot walloping. Smoke is the most precise form of fitting to, particularly to steel substances or surfaces together. So if the smoke is there when you remove it again, it means that the part is slightly smaller by a micron or two than the part it fits into. Whereas if the smoke is gone, it means the diameter is precisely or maybe a micron less. It would need some bit of force. And then if it's any bigger than that you have to force it in, it's an interference fit. It's an interference fit. So usually with interference fits, they'd heat the female end part and they'd shove the male end in while it's hot, and then it compresses on it. But you wouldn't use that if it's expected to be prized open again. So you'd often use the smoke to get you the most exact measurement, and that can't be done by any vernier calipers, any micrometer calipers, or any internal calipers. It's not adequate enough. A calipers only measures from here to here. Do you see that? It only measures from here to here. So for example, here's a micrometer calipers, 2-inch imperial, an old one I have. So you can certainly take a measurement. You see there, like, there's a rather tight fit there. Do you see that? It'll go in there. But it will. But you still have the human hand involved, which is not a good thing. You see that there? See it there? Probably fall on me now. Wait a minute. Yeah, do you see? But that's only measuring across the diameter. It's not measuring the roundness of it. So that could be perfect according to the micrometer calipers, and yet when you'd put that into a female receiver, you wouldn't have it right round. For very precise work, for aircrafts and a lot of good engineering processes, and I'd say Rolls-Royce engines would be an example, even some internal combustion engines, they'd expect that would be smoked, and then it'd be pushed into the female end, and when it'd be taken out again, the smoke would be gone. That tells them exactly how tight it is. So just to explain that to you, a lot of ignorance jackasses think that if you're using smoke for precise engineering, you're a curmudgeon. No, you're not. You're actually using a very very old craft to use acetylene smoke. Now, a candle. I often use a candle when I wouldn't have acetylene smoke, but you don't need acetylene bottles. All you need is a bit of carbide and a wee bit of water and a wee bowl just to burn it, and it does that. So I think I've explained that. There's an example of an internal there. You might be putting something in there. Now, also with flat surfaces, with certain flat surfaces, you'd be using the smoke as well. But you wouldn't be doing it for rough work. You certainly wouldn't do it for any kind of rough work at all, any kind of rough work. Well, seating valves. If you had valves on an engine and valves on a cylinder head, certainly when you'd have your valves grind, you would expect that there be no traces of smoke. So that's another very good example, actually, the smoke. If the valves on an engine, the poppet valves that's on all engines really, you might try them out with a bit of the smoke. They should be clear of smoke. If they're not, they need more regrinding. So I'd say they use it in industries for that as well. There's no real any other way of knowing that your valves are seated perfectly to make sure that no gases escape. Of course, that's the ideal world. Whether that's all is done, there may be other methods of doing it too in the modern world and equipment for doing it. And there is high electronic equipment. But would you believe it, in a lot of very strong craft shops, like if, for example, the clocks that the Queen would have in Buckingham Palace, all of the surfaces that have to be precise are done by smoke. They were all made by smoke. Even the gear wheels, where they engage with each other, they'd make them so that they clear the smoke. In other words, when they run against each other, the smoke would remain on the pieces, on one of the pieces, and that, but only no more. So if it started to clear the smoke, a little bit would be filed off and they'd come again until they got the smoke right. That all cost a lot of money for very rich people. That's what they have. For a lot of jet engines and aircraft, some things have to be unbelievably precise. It's still one of the best old and tried and true method there is. And acetylene smoke is the thinnest apparently, although we use other things, but acetylene smoke, it was always what they used. Right, we let you go on that. Thanks, Vintage Workshop, on the 1st of August 2025. Sorry for rambling on a bit, but you don't have to look at it. And I meant to say at the beginning, only watch it if you're interested, but sure, we'll put on the caption. Thank you.